Hello, I'll be presenting a project which uses process control principles. On the screen you can see a diagram showing the situation, and I'll read through this introduction. With the advancement of research and application of self-driving cars comes opportunity for further development of roadway infrastructure, including traffic signal communication systems. Currently, self-driving cars use a complex array of optical sensors to relay traffic signals and other constraints to the control system, simulating a human response. However, as communities begin to rely on self-driving cars, adaptive infrastructure can be implemented to improve performance beyond the abilities of a human response. One possible improvement is for traffic signals to send constantly updating and preemptive information about the speed limit, block length, and time delay until the red light. Using this additional signal information, the controller can more easily decide if safely passing the intersection is feasible and can produce a braking scheme which improves comfort for the passengers and reduces the overuse of braking systems. So I'll change screens here to a Spider script of Python, where I have prepared a simulation which will show the advantages of using this preemptive signaling system. This first set of constants are used for the first order plus dead time model, which describes the deceleration of the car. The gain is produced from a car which at 100% brake would reduce speed from 62.1 to 0 miles per hour in 40 meters. And the tau, which is the time constant, is found at 0% brake with a reduction from 45 to 40 miles per hour in 3 seconds. These are general approximations for a car in the United States, but these values can be adjusted for a given car. Finally, a dead time, theta, is approximated at about a quarter of a second. Each signal, as described before, has 3 pieces of information: a posted speed limit in miles per hour, a city block length in meters, and a time to red, which is the time before a red light will flash, in seconds. All 3 of these can be adjusted to give different situations, and the code has been prepared for a normal range of these values. The block length has very little influence on the ability of the controller, but in the United States it is standard for a block to be about 100 meters. The posted speed limit can be in a range of values from 55 to 25 miles per hour, and it was tuned to these values because these are the normal speeds that a traffic light would be used. The time is dependent on when the car enters the block before the intersection and can vary significantly. And so a chart has been provided below which shows a good example time for several different cases. Everything from good to go being times at that speed where the car would clearly make the light, before yellow, which are cases where this preemptive system is useful, with yellow being that the signal would come in at the same time as the yellow light triggers, after yellow being times where the yellow light would have already triggered before the car entered the block, and with red being the car enters almost at the same time that the red light changes. On the right you can see graphs which have been presented where we have percent brake against time, distance against time, velocity against time, and velocity against distance. where orange in all cases represent the signal coming in, yellow represents the yellow light, red represents the red light. And this double band of blue shows the right one being the beginning of the intersection and the left one being the beginning of an offset measurement, here representing about half a car length, but this is a goal for the car to stop by. And so we can see if we adjust, say, to 35 miles an hour and going 4 seconds before the red light, we can run this program and see that the graph adjusts and shows us the best situation for these. Because we want to compare to a regular traffic light, we can switch show yellow to 1, which initiates a comparison to a traditional traffic light. Again, we can show a different value, say 45 miles per hour, and 5 seconds before the light turns red. And if we do so, it will think for a moment, and the graph will come up, and we will see this yellow dotted line in all cases represents the same graph, but only if a traditional traffic light is given. The largest variation comes from the brake. In order to create a very similar response for the passenger's comfort, a much stronger brake response is required. Here above you can see a comparison using a unit of brake percent seconds, which is the area under these curves. And you can see that the signal has a much lower value than the traditional yellow light. And so you can see visually and quantitatively the improvement that this preemptive decelerator system has. In conclusion, as time progresses and people become more comfortable with self-driving cars, process control principles will have many applications in furthering our quality of life and the safety of our vehicles. Thank you for your time and your interest in my project.